Hello YouTube, this is the Atlanta Puzzler with part 4 of the Advanced Megaminx tutorial series. If you haven't watched parts 1, 2, and 3, you can watch them, you can find a playlist on my channel and you can view those videos and catch up on where we are. But basically we talked about how to vary the depth of the cut on a standard Megaminx design and produce a Pyraminx Crystal or Starminx, and we talked about Pentultimates and other designs. We also talked about conical versus cylindrical cuts. We kind of touched upon them. We didn't discuss the mechanics. But basically, I wanted to make this last video because there's another type of cut that we did not talk about. And I don't know what it's really called, but it's called something like a corner cut potentially, instead of cutting under the surface here. Like if you see, like when we create a cutting surface, the brim of the surface is parallel to the face, and that's not necessarily the case. And you would do that with a Starminx or other puzzles. I only know of a Starminx personally, and it produces a different type of it looks, on the outside it looks just like a Starminx, but it turns different. I guess it's called a corner turning Starminx or super Starminx, or I'm sure it has a name, I don't know, master Starminx or something like this. But basically, in order to show you what I'm talking about, I kind of modeled it here really quick in a basic assembly. And basically the corners, the corner rotates and it drags the edges along with it, and instead of just a standard Starminx. So if you look at your traditional Starminx, you'll find that these faces are what turns. It turns along these lines here. This one has a slice that is like a shallow slice, rarely just going under the vertex here, and it gives you this rotating effect. And I don't know what category it goes under. It's just it's a different type of cut that I've seen. So let me show you. Basically, this is, I did this by slicing off this face right here off of my dodecahedron, and I created this circular cavity that allows the corner to spin, and it drags the edges along with it. Now personally, I've never 3D printed this part. I've never ordered it to be printed. I just reversed engineered some models, and I kind of, oh, okay, I see how it works, but I've never actually my only experience is theoretical. I've never actually applied it in real life. But I just wanted to talk about it really quick, just to get you familiar with it. And if you're curious how I made this cut, I'll show you really quick. I don't want to spend too much time on it, to be honest, but I think it's worth talking about. So I'm going to use these tools that NKCube recommended in his series. Those are the ones I referenced in my part 1 of this series. But basically, I'm going to use a polyhedron generator in the origin and use a dodecahedron. And usually like these to be small. The size is irrelevant in this case, so I'm going to do OK. And let's make a sketch on the right plane, and let's do a few construction lines here. I'm going to do one this way, and let's make one that's straight up vertical, and that's it, I guess. And let's choose this vertex. So this is actually important. We're looking at this edge over here, the one goes along this line. I want the construction line to go through this vertex here, so I'm gonna make these two coincident, and I need I need a line that goes, a cutting line that goes in this vertex, in the opposite vertex basically. And I hope this is clear. So we basically pay attention to this edge. I need my cutting line to go through this vertex over here. So to do that, let's just make a line quickly that goes this way, and you want it to stop near the vertical axis. Okay, so really quick, let's choose the vertex and the line and make sure they're coincident. And now one thing very important, we're going to revolve this cutting line around this axis. So you want to make sure these two are orthogonal to one another, or perpendicular, same thing. And if you don't make them perpendicular, you're going to end up with a conical cut and you're going to have a curvy shape and whatever. So make sure you add this perpendicular constraint. And next, you want this line to kind of bend downwards. I always think of this, it reminds me of, if you're familiar with physics, Snell's law in physics, how light or beam refracts downwards when it enters a body. So this comes in and bends, and this bend exists in pretty much any cut that you're going to make. Okay. And the reason why it's important, because it gives you that body or the thickness of your part. Otherwise you're gonna end up with a very pointy or sharp edge of your puzzles, and you're not gonna have a good mechanism in place. So anyways, I'm gonna add another center point arc that goes into this edge over here. And don't worry, I'll make another video where I go in depth into this stuff. But even if I don't, I mean, this is a standard mechanism, exactly how we made the Megaminx, if you remember. So I'm gonna do OK, and let me make a revolve here of a surface, and let's choose the different parts and make sure we revolve them around this part over here, and do OK. And let me hide the part, and what you get is a standard flat cutting disc with a standard mechanism. But what's important to pay attention to is that it's slicing off this pyramid looking shape. It's not, the cut is not under it's not under a face of one of the faces of the dodecahedron. Typically the disc is flat under it, but in this case it's not. It's under one of the vertices, as opposed to being under one of the centers of the dodecahedron. Okay, so we have to pattern this and cut it basically, and the easiest way to do this is, again, these nifty tools, construction axes. Let's choose the origin, faces. Okay, let's do through faces, and this is the polyhedron, and I don't know, 100. There we go, and do OK. So now we have all these construction axes, and let me hide the faces. And we don't have to, I'm not gonna pattern the whole thing. I don't think my machine will handle it now, but let's do let's pattern the disk around one of these faces. Let's do this face, and we want to do it, I think 3 times, was it, or 5? Yeah, 5 times. Let's do OK. And let me make sure if it's 3 or 5, I can't remember. But let's do a multi-split. And for the bodies, let's choose the dodecahedron. And for the surfaces, let me choose those 5. surfaces. And let's see if this will give me a valid cut. And it did indeed. And do OK. And you'll see it gave me the bit what looks like a Starminx, but it's actually a corner turning Starminx, if that makes sense. Because this piece is not cut all the way. Actually, sorry, let me let me hide this body. But I was gonna say, I don't know if I hide these puzzles, these parts, you're gonna see the correct mechanism. Okay, it's almost there. And basically, what you're seeing here is the corner, but it's not fully broken down, or some of it is actually. Let's hide these. Okay, so we have the edges here, and I don't have any corners, I guess. Let's see if I can show you some corners. And by the way, these are not complete. I'm just saying it's sort of like it gives you the outline of how the parts will look like. And again, like I said, I'm not an expert in this part, but I did play around in this puzzle, in designing this puzzle. I did play around with an existing design a while ago, and basically just got familiar with how the cut is done. Let me hide other parts and see. Okay, this looks funny, but okay. Basically, this is what's going to become a center, and you have to slice it off with a sphere to free it from the body. And what you'll end up with is all all these faces here are sliced, and you'll end up with centers instead, and so on. So don't worry too much about this. I just want you to be familiar with how you can take your slicing discs and rotate them around, um, uh, or basically slice under a vertex instead of slicing under a center of a face to give you these corner turning puzzles. So this is like, relatively speaking, this is like an advanced kind of concept. It's not really hard at all, but I wouldn't get into this before I master the other more conventional puzzles, and then this will just be like a straightforward puzzle to design. So okay, I'm gonna stop the video here. I hope this particular part made sense. I hope kind of brought up to your attention some of the variety of other puzzles that are out there, and how they're built. We'll talk about all these parts in subsequent series in details. I would like to get all these all the knowledge I have. I'm not an expert by any means, but I did play around with using Onshape with many other designs, and I'd like to get all the knowledge in my head captured in videos, and share it with the public, so I won't forget it and it doesn't get lost. Okay, so I hope you enjoyed this series. Please leave me any comments or questions if you have any, and if you want me to elaborate or start with a particular design instead, and we'll go from there. And I'll try to create a series every weekend, and depending on my time, if I'm not too busy. So thank you very much, and I'll see you in the next series. Have a good night.